Lesson 31 is subtracting fractions. Go ahead and write that down into your notes for the title and push play when you're ready to begin. So I think you'll like this lesson because it's very similar to what we have been working on. So it really is just giving you a chance to practice some skills that you've been working on with addition in fractions. I just want to remind you of what a fraction is. It's really important that you understand what a fraction is as we're working with fractions. So fractions are just not a whole amount. So here are some examples of what a fraction could represent. It could be a partially eaten pizza. So here's a pizza, pepperoni, because that's my favorite type of pizza. And it's not a whole pizza. It's not one full pizza because somebody ate some of it. Somebody ate two of the pieces here. They ate that and they ate that. So it is a partial pizza, so it's a fraction of a pizza. You can say there's 4/6 of a pizza because 1, 2, 3, 4. 1, 2, 3, 4 of the 6 total pieces are still there. Or if you wanted to just say what was eaten of the pizza, you can say 2/6 was eaten and 4/6 is left. It is just not the whole thing. Another example of a fraction, coins that don't add to a full dollar. If you have 75 cents, you do not have a full dollar. That's 3/4 of a dollar. It's a fraction of a dollar. So fractions are only part of a whole, not enough to make it a whole amount yet. If you went running, a run that is less than a full mile would be a fraction of a mile. I only ran 3/4 of a mile, or I only ran 1/2 of a mile. I did not make it to a full mile. So fractions are part of a whole. So we want to make sure that that gets kind of stuck into your head. Okay, so to subtract fractions, these steps are going to look very familiar to you. If you have same denominators, you just subtract the numerators, leave the denominator the same as it is, and be done with it. If you don't have same denominators, you need to get the same denominators. Just like we said in the previous lesson, you need to cut those pizzas in the same way. So we use the LCM of the denominators. So we find LCM of those two denominators. Then we bully the fractions while keeping them equivalent. Subtract the numerators. And then if it needs to be converted, if it's improper, convert it to mixed. If it's proper already, don't do that because you can't. So just if it's improper, convert it. If it can be reduced, the fraction can be reduced on the answer, then reduce it. So this step does need to be done. This is a very often forgotten step, so don't forget that guy. Go ahead and write down these steps into your notes. Push play when you're ready to begin. Okay, and let's we do number 1. Go ahead and copy this down into your notes. This is 5/7 minus 1/4. Now my denominators are not the same, and so we handle this exactly the same way we did when we added fractions. We need to get those denominators the same. Our pizza needs to be cut up the same amount in order for us to compare those and take any away. They have to be the same size. So what we'll do is we'll find out if we counted by 7 and we counted by 4, what's the lowest number they would meet at? Well, when we're trying to figure out the lowest number or something would meet at, we're doing LCM. So we'll do the LCM, and we learned to use the ladder to pull out common divisors and get numbers down to their lowest form. In this case, there's nothing that goes into both 7 and 4, so I'm stuck right away. 7 times 4 is 28. So my lowest common denominator is going to be 28. So I'm going to have two fractions, or two pizzas, cut into 28 slices. And I have to make sure that I keep these fractions equivalent. So I'm going to ask myself, what did I do to 7 in order to get him to 28? Well, I multiply him by 4, that's right. And what do I do to his best friend then? Well, if I beat him up with a 4, I better beat his best friend up with a 4 as well, so that it stays equivalent. It stays the same amount. And 5 times 4 is 20. And what did I do to this 4 to get him to become a 28? I multiplied him by 7, is right. Do the same to his best friend. And now that my denominators are the same, I keep it the same. And then I do 20, take away 7, which is 13. Last step I need to do, convert if I need to. Well, convert means it's improper and I need to make it mixed. But this is not an improper fraction. This is a proper fraction. It's a right side up snowman, so he's fine. No need to convert. Reduce if I can. Well, 13 is prime, and it doesn't go equally into 28, so there's no reduction going to happen on this one either. So this answer is done then. The answer is 13/28. All right, let's do another redo. Let's do 5/9 minus 1/6. Go ahead and copy that down. And let's go ahead and solve this one. Again, what we need to do, and I put the steps here. So what we need to do is we need a common denominator. And right now 9 and 6 are not the same number. So we need to count by those numbers to find the lowest number that they will meet at. And we could do that, count by 9 and count by 6 and see where they meet at. Or we can use the tool that we've learned that does that for us, and that's to find the LCM of those two numbers, 9 and 6. Well, 3 goes into both of those evenly. 3 fits into 9 3 times, and 3 fits into 6 2 times. And then is there anything that fits into both 3 and 2 evenly, except for 1, other than 1? No, we're stuck there. So we go ahead and we multiply the L. 3 times 3 is 9, and 9 times 2 is 18. So that's a nice little trick to help us find which number they'll meet at, the LCM. So now we know that we need two fractions with a denominator of 18, because that was the lowest common point that those two denominators would meet at. Okay, so now I just need to go around. I'm on step 2 now. I'll bully the fractions, make sure to keep them equivalent. So what do I do to a 9 to get him to become 18? Oh, well, I would multiply him by 2. And I would do the same to his best friend. 5 times 2 is 10. And what do I do to 6 to get him to become 18? What do I multiply him by? 3 is right. And 1 times 3, so do the same to his best friend. 1 times 3 is 3. Okay, now I have denominator 18, and I'm going to add 10, or I'm sorry, I'm not going to subtract 10 minus 3, and 10 minus 3 is 7. Check the last step. Convert if it's improper. This is proper, so I don't need to do that. Reduce if you can. That's prime and doesn't fit exactly into that, so I'm stuck. And that's your correct answer. Very much similar to adding, except with fractions, except now we're just subtracting. All the steps are the same. So those steps really should be clicking nicely into place and becoming easier and easier. Okay, because this is so similar to what we've been working on, I think 2 we-dos should be sufficient. And so let's go ahead and go on to a you-do and see how you do on it. I've placed the steps there. Go ahead and do 3/4 minus 2/6. Pause the video. You want to make sure to try this on your own so you know where you're getting stuck at, and then push play when you're ready, when you either have an answer or when you've gotten stuck. Okay, now you have some sort of an answer. Let's see how you did. The first thing I need to do is my denominators are not the same, so I'm going to use LCM because I need to count by 4 until I get to a number that I would get to if I counted by 6, the lowest one that they match at. Well, when you need to count by numbers and find out where they meet, you do LCM. So I'm going to do the LCM of 4 and 6 to find out the lowest point that they meet at. I could count by those numbers and find it, and maybe in your head now you can probably do that with those two numbers. But if you can't with those numbers, this tool that we've been using, the broken ladder, pulls out common divisors from them. We're dividing the same numbers into them, so we're pulling them out of there, and it helps to break it down to the lowest common multiple. So I look at those and I know 2 goes into both of them. 2 fits into 4 twice, 2 fits into 6 3 times. And there I'm stuck. 2 times 2 is 4, and 4 times 3 is 12. So the lowest point that those two numbers will meet is at 12. So I need both of those fractions to be fractions that have a denominator of 12. So I'm now on step 2, bully the fractions to keep them equivalent. What do I do to 4? To get him to become a 12, I multiply him by 3, and I do the same to his best friend. 3 times 3 is 9. What did I do to 6 to get him to become 12? I multiplied him by 2. I do the same to his best friend. 2 times 2 is 4. Now, I subtract the numerators. I keep the denominator the same. 9 take away 4 is 5. And finally, check for if you need to convert this. Is it proper or improper? This is proper, so I do not need to convert it. He's happy snowman. Reduce. I cannot reduce this. There is nothing that goes into both 5 and 12. So the answer you should have gotten was 5/12. That was the correct answer. If you got that answer and you understand how to do this, go ahead and come get the closure questions so you can show me you get it. If you are still a little unclear and you want to rewind and review any of the parts of this lesson to help you understand it, go ahead and do that. And if you're still not clear after doing that and you want me to explain it further, come see me and I'll go over it with you a little bit more.